Okay, this video is going to go over solving systems by graphing, specifically quadratic linear systems. What that means is you're going to have one equation that's a quadratic, like this, and you're going to have one equation that's a linear. And basically, you're going to find out where these lines crisscross. So let's go ahead and get started here. The first one, I would graph the quadratic first. So I'll do that in blue. You have a vertex of -1, 1. And then it's just an a value of 1, so it's going to look something like this. When you graph these, you really want to be accurate. If you're solving these by graphing, you need to be very accurate. Okay, the next one is this linear function, -x plus 2. That's in mx plus b form, so it has a y-intercept of 2, then a slope of -1, so that's fall 1, run 1. So it's going to look something like this. Okay. So now when they say solutions, you're just finding out where these things crisscross, and then you're going to answer with the x values. So it looks like they crisscross at x equals -3 and at x equals 0. And that's basically how you do all of these. So look at this next one. You have your quadratic function, vertex of -1, -5, an a value of 2, all right, so this line's going to look something like this. All right, and now I do my linear one, which is mx plus b, 2x plus 1, start at a y-intercept of 1, rise 2, run 1, work your way back. It's going to look something like this. Then you just find out where they crisscross. So that'd be here and here. That's at an x value of -2 and an x value of 1. So that's best case scenario because they gave these red lines to us in mx plus b form, slope-intercept form. Sometimes though, they're going to give it to you in standard form, and you're going to have to change it to slope-intercept form yourself. So you want to get it to say y equals mx plus b. Notice y is by itself. So anything that's on the side with the y is going to have to move to the other side. So you'll end up like this, y equals, I like to put the x first, so -3x minus 2. And really it's -3 over 1x minus 2. Your slope is -3 over 1 there. Okay, this next one, just get y by itself. So get rid of this right here, the -1/2 x, by adding 1/2 x. And then again, when I rewrite this, I like to keep it in mx plus b form, so that's 1/2 x plus 5. This last one, this is how you'll probably actually see it. You need to move the x first. Then you divide by this number in front of the y, so -4, and everything gets divided by -4 over here. So what this turns into is -2 over -4 is +1/2. -2 over -4, +1/2, like that. All right, let's look at some more examples. On these, we're going to have to make it the linear one in mx plus b form. I just showed you how. So this first one is going to change to -1x minus 6. All right, go ahead and graph your quadratic. You have a vertex of -2, -6, an a value of 1. All right, so this line looks something like this. That wasn't very good. Let me try again. All right, now I need to graph the linear function, -1x minus 6. So start at your y-intercept of -6, fall 1, run 1, work your way back. So it looks something like that. Find out where they crisscross. That would be here and here. That's at an x value of -4 and an x value of -1. This next one, I'm going to go ahead and change this equation to mx plus b form. So I'm going to -5. All right, now I'm ready to graph. So I'm going to graph my quadratic first. Vertex at 3, 4. A value of -1. All right, now graph the linear function. Start at your y-intercept of -5. You are rising 2, running 1. All right, now look at my blue graph here. I did not go far enough. There's going to be an intersection somewhere right here. I need to find out where. So I'm going to go a little bit further with my quadratic here. So I'm going to plug in an x value of 0 and get -5. So it actually looks like this. So the places where it crisscross are here and here. That's at an x value of 0 and an x value of 4. Okay, these last two. This one's already in mx plus b form for the linear, so I'm just going to go ahead and start by graphing the quadratic. Vertex of 3, 2, a value of 1. Graph your linear, 1/3 x plus 1. So start at your y-intercept of 1. Rise 1, run 3. Now this one's interesting because we only have one place where we intersect at an x value of 3. You don't always have to intersect twice. Sometimes you'll only hit once. Sometimes you won't hit at all. We'll see what this next one looks like. The linear is already in mx plus b, so I'm going to start just by graphing my quadratic. Vertex of 4, 3. A value of 1. Okay, now I graph my linear function. -1/2 x plus 4. Start your y-intercept. Fall 1, run 2. Okay, now, so on all the previous, we've been hitting twice, except for this most recent one, we only hit once. But you don't always have to hit. Sometimes you won't hit at all. When this happens, it's no solution. So just be real accurate with your graphs if you're going to solve these graphically. Hope this video helped.